Welcome back. So we've talked about the basics behind earthquakes, how, where they occur, different types of faults, seismic waves, how we measure earthquakes. So what differentiates this geology class from some of the other ones that we offer here is we talk a lot about how these natural hazards and disasters impact society. You know, whether it's life, economics, politics, whatever it may be. So let's take some time, shall we, and talk about such. All right. Oops, the tasers. So this is a map of, obviously, the United States that looks at the hazards of a place just having an earthquake, regardless of how big or how small it would be. If we look at Arizona, there is a kind of mediocre hazard-ish associated with where we live. But if you look at some place like California, it has the highest hazard. In fact, most of the West Coast sitting on a either convergent or transform boundary, you're going to get a lot of earthquakes over there. So no surprise there. No surprise there. You're looking in the middle of the country and not much there, but there are some spots that are kind of, again, away from a plate boundary, but yet still have a very high hazard of the earthquake even occurring there. Look at what's happening in the Missouri, Arkansas, Tennessee, Kentucky area. Very high hazard. Ancient faults. This would be an intraplate earthquake. Same with South Carolina here. Even in a little bit into Tennessee, North Carolina area. Again, these are nowhere near boundaries, so these would be considered intraplate earthquakes where there's most likely some sort of ancient fault system, but the movement is still occurring at least every 10,000 years. And one of probably the most interesting areas to look at is this little blip here in Oklahoma. What you're seeing here in Oklahoma, there's no ancient faults. There's obviously, it's not near a plate boundary, so there's no just normal earthquake activity. This kind of increase in hazard in the Oklahoma area is due to something called fracking or hydraulic fracturing. It's the mining out of natural gas and then the pumping of waste material back underground that is fracturing the ground, essentially lubing it up, and then causing the ground itself to kind of shake and jiggle. So there's a high incidence of earthquakes in the Oklahoma area. More on that in a little bit. So what this map looks at is the frequency of damaging earthquakes shaking around the U.S. So a little bit different than the previous slide. Those are just any types of earthquakes. So this is the kind of the incidence of a location actually having an earthquake that does some damage. So the dark red, again, California, no surprise there, is the indicates that there are over 250 expected number of occurrences of damaging earthquakes in 10,000 years. All right, so that's, one every 50 or so years-ish about. One every 40 or 50 years is going to be really damaging. So, these are in these areas. So, somewhat common as you get further down that scale. So, again, this is looking at destruction. But again, still in that Missouri area, high incidence that they're damaging, so larger earthquakes will occur. And the ones that we find in Oklahoma due to this fracking, which is a man-made, what's the word I'm looking for? Function, which creates these earthquakes. Again, they're usually small, so not that damaging. So same with Arizona, all right, but obviously more common California, up the West Coast, into Alaska, etc. So again, focusing on that Oklahoma area. So this is a chart that looks at the earthquakes from 1973 up through 2020. Again, there's no ancient faults in these areas. It's not near a boundary, so these are strictly man-made earthquakes. So you can see from the 70s through the 80s, 90s, and most of the 2000s, very little, so about 867 magnitude 3 earthquakes or above up until 2008. But then in about the last 10 years, you see it spike just out of nowhere. That's not just because something different with the earth is happening. It's because this is when that fracking, the hydraulic fracturing drilling for natural gas, this is when it really became a big thing. All right. So, yeah, Oklahoma, a lot of earthquakes. Who knew? So looking at this 5-year period, so a little more statistics to throw at you. Sometimes we look at the numbers and make sense of the patterns in what we see to help us make sense of the hazard and or event. So in this 5 or 6 year period from 2010 to 2015, this is just a few states looking at numbers of earthquakes, how it's relatively consistent. Again, Alabama, you don't really get much. Alaska, you do get in the thousands every year. It does sit right along a convergent plate boundary. Arizona, not so much. Maybe a little jump here, but single, double digits. Arkansas, California, it gets a lot, so in the hundreds. But again, looking at Oklahoma, going from double digits to jumping up to almost 1,000 in that 6 year period. So something weird's going on in Oklahoma. Darn you, Oklahoma. And again, those are man-made, but regardless, whether it's man-made or whether it's some of these earthquakes in Missouri or South Carolina, these are all earthquakes that are away from plate boundaries. Remember in the first section, we talked about most earthquakes occur at plate boundaries, at or near plate boundaries, convergent, divergent, transform plate boundaries. So it's rare that they happen other places, but they do occur. And these are some great examples. Again, Oklahoma, that's more man-made, but these others are natural. So intraplate earthquakes, again, they're rare, but they can be large and extremely damaging. And the reason being, because they happen less often and in areas that you don't typically associate with earthquakes, people are less prepared. Buildings are not necessarily built to withstand earthquakes because that's not in mind. People's houses aren't built to withstand earthquakes because, again, that's not in their minds because earthquakes are so rare. But when they can happen big and cause a lot of damage. So it is kind of dangerous to live in some of these places if an earthquake occurs. Living in California, obviously a lot of earthquakes, but buildings are built to withstand that. Houses are built to kind of withstand and take some of that shaking and not crumble. They're built with certain codes. Other places they're not. But a lot of these intra-plate earthquakes are due to, again, ancient faults, ancient breaks, movement, and there's still movement. And as long as there's some sort of movement occurs every 10,000 years or so, it's still considered an active fault. So these are still active fault areas. Just they don't commonly have big earthquakes. So out of sight, out of mind, unfortunately. And it can creep up on people. So when an earthquake occurs, if you've watched, San Andreas with Dwayne "The Rock" Johnson, the things shake and things fall down. But there's other stuff that occurred in that movie. It wasn't necessarily scientifically accurate, but, it did bring to light some things that also can occur that go along with earthquakes. So the ground quaking, that's just the primary hazard associated with earthquakes. This is damage directly related to the ground shaking. So because the ground shaking, the building fell over. Because the ground was shaking, the bridges collapsed. Because the ground was shaking and split open, the roads fell into the earth. All of that damage is directly from the shaking itself. But sometimes, just sometimes, it's other things that can cause just as much, if not more damage than the original quaking itself. And we call those secondary hazards. It's when the quaking causes something else, some other destructive force. So the earthquake itself didn't destroy my house, but the earthquake caused a landslide, and the landslide came and destroyed my house. Secondary hazard. The earthquake didn't destroy my house, but the earthquake ruptured a gas line, which set the forest on fire, which burnt my house. Or again, the earthquake didn't destroy my house, but it caused a tsunami. More on that in a later unit, which rushed in and destroyed my house. So these are all secondary hazards. Disease is another one of those. If water and food supplies are cut off, if sewer lines are broken and you got poop everywhere, you could cause disease. So the earthquake didn't kill me, but the disease did. As well as something called ground liquefaction. Ooh, this is a fun one. If ground is waterlogged, typically near some large body of water, so typically near the shore of an ocean, etc., etc. As you start to jiggle and shake that ground, if there's a lot of water in there, in essence, that water begins to liquefy. So it's called ground liquefaction. And it turns into like a quicksand. So what you see, this little car here, that's not half a car sawed in half and placed on the ground. So looking at the palm trees and kind of this sandy material. So this looks like some area near shore, someplace tropical. Earthquake occurred, ground liquefied, sucked that car right in. So it's now buried in the ground. That doesn't only happen with cars, it can happen with buildings. All right, you can kind of see what looks like the shore here. Again, here's another instance of a car being swallowed. This is liquefaction. Right? So the shaking itself didn't destroy the building, but the shaking caused the ground to liquefy, and then the building fell due to the liquefied ground below. So secondary hazards, not always, but a lot of times they can cause even more damage than the original quake. Scary. For more information on liquefaction, please watch these videos. The first is a little bit of an explanation on liquefaction. The second is a little demo to show you kind of how it works. And 3 is a weird example. There's some language. They use the F word. So if you don't want to watch it, that's fine. But it's interesting. It's a weird example of liquefaction. So make sure you're watching that. All right. So I tell you what, this section's a little bit longer. Let's go ahead and pause here. When we come back, we'll continue this talk about impacts of earthquakes on society. We'll go over some of the deadliest earthquakes, the costliest earthquakes, to kind of maybe wrap up this section. But before we do, let me give you another piece of the super secret code. It is the number 2. You got me? The number 2. One more time. The number 2. So we'll pause here. I'll see you back in just a minute.